Have you ever watched AI models churn out text, character by character, word by word, and thought? There has to be a faster way? Well, prepare yourselves, because a new player has just entered the arena, and it's not just fast. It's insanely fast. So fast, in fact, it's humiliating every top model out there. For years, most AI models have operated like a meticulous typist, slowly predicting each next word based on the one before it. Think of your everyday chatbots or coding assistants. That step-by-step process, while intelligent, creates a serious speed limit. It drags down performance in everything from complex code generation to real-time interactions. But now, there's a new model, aptly named Mercury, that shatters this limitation completely. Instead of guessing one token at a time, Mercury generates many at once. It achieves this through a method called diffusion, a concept that's made image generators incredibly powerful, but has never been applied at this scale for language. And the results? Truly shocking. It's not just faster, it's on a completely different level. The brilliant minds at Inception Labs looked at that sequential bottleneck and simply asked, why not jump tracks entirely? Their new model family, Mercury, embraces diffusion. Imagine starting from random noise and tidying it up, step by step. But here, those steps happen across every position in the sentence at once. Thanks to modern GPUs, which are built to crunch loads of matrix math in one go, Mercury ends up blasting out code far faster than the older approach. Let's talk numbers, because this is where it gets wild. The smallest public version, Mercury Coder Mini, has been clocked at an astounding 1119 tokens per second on an NVIDIA H100 card. And the slightly larger Mercury Coder Small Still churns out 737 tokens per second, while adding a bit more brainpower. These aren't just marketing claims, these speed readings come from Artificial Analysis, an independent firm that times models under the same rigorous rules. This is the real deal. Of course, speed isn't the whole story. A coding assistant that misplaces a bracket isn't helpful. So, the Mercury crew rigorously measured quality on the usual scoreboards. On HumanEval, which asks the model to pass hidden Python tests, Coder Small reaches an impressive 90%, and Coder Mini lands at 88%. MVP, another Python test set, shows 76% for Small and 77% for Mini. And on Eval Plus, which repeats those tasks with stricter hidden checks, Small still maintains a strong 80%. Then there's MultiPL, which spreads questions across C++, Java, JavaScript, PHP, Bash, and TypeScript. Here, Small averages 76.2%, while Mini averages 74.1%. In short, the larger Small model sits right with frontier speed-tuned offerings like Claude 3.5 Haiku and Gemini 2.0 Flash, while staying 3 to 10 times faster. The smaller Mini model gives up only a few accuracy points, yet still outruns almost everything else in sight. The magic happens because diffusion lets the model polish the whole answer together. Traditional models build answers from left to right, one word at a time, like typing a sentence, and never being allowed to go back and fix anything. But diffusion flips that idea completely. It works more like editing a shared Google Doc, where you can tweak any part of the answer at any time, even go back and rewrite the start after you've written the end. This is especially useful for coding, where something you add at the bottom might change what needs to happen at the top. And because each pass updates the whole thing at once, it runs way faster on modern graphics cards, which are built to handle tons of calculations all at once. During training, Inception Labs took trillions of tokens, no exaggeration, from a blend of web crawls, synthetic examples, and proprietary repositories. They add controlled noise, then teach the transformer to denoise step by step, weighing easy and hard steps differently. This means the model first sketches broad structure, then perfects details like indentation and naming. From a developer's seat, nothing exotic changes. The public API speaks the familiar OpenAI JSON dialect, which means a swap is basically changing one base URL in your client code. And context window length? Mercury ships with 32,768 tokens of context out of the box, and can stretch to 128,000 with an extension trick. That's long enough to drop in a whole Kubernetes manifest plus notes and still have room for instructions. Early testers report that chain of thought prompting, few shot, and zero shot all still work, which makes sense because the conditioning interface remains unchanged. To see how humans react, look at County Pilot Arena, a blind taste test site where developers choose between code snippets without knowing which model wrote them. Mercury Coder Mini tied for second in overall ELO score, yet delivered the lowest average latency, just a quarter of a second. GPT-4o Mini, Codestrel, and Gemini Flash needed several times longer to draw their first characters. Reviewers even noticed Mercury's answers felt concise, with no surplus verbosity, perhaps because global parsers discourage token fluff. It's truly worth stacking Mercury against the usual top performers. GPT-4o Mini reaches similar accuracy but tops out at just 59 tokens per second. Claude 3.5 Haiku sits around 61. And even Gemini 2.0 Flash, with its high-speed mode, barely touches 200. Meanwhile, Mercury, pushing over 1,100 tokens per second, still outperforms them on the speed-to-quality curve as shown by artificial analysis. Even the heavyweights like GPT-4o Full and DeepSeek version 3 struggle to break past 100 consistently, making Mercury's numbers feel almost unreal in comparison. A fair question pops up: isn't Diffusion famous for needing dozens, even hundreds of iterations when generating images? That's true in pixel space, but text diffusion can cut steps sharply. Because the denoiser proposes big edits early. In practice, Mercury often takes between 10 and 30 passes. Added together, those passes still spend less time than one autoregressive rollout, because every pass covers the entire sequence at once. Another common worry is resource use. The 1,119 tokens per second headline comes from an H100 with hand-tuned kernels. You won't hit that figure on a desktop 3090 using plain PTorch. Today, Inception Labs fuses operations in custom CUDA kernels, manages memory to avoid unnecessary transfers, and schedules batches centrally. Whether those improvements trickle down to open source remains to be seen, but history suggests community ports follow soon after commercial debuts once people see the gains. There's a green angle too. If one GPU serves 10 times as many tokens in the same time slot, cloud providers need fewer racks, and smaller organizations can stay on smaller clusters. That lowers the bill and the carbon footprint. As more devices move inference to the edge, think office laptops or on-premise servers, these savings become practical, not just theoretical. The Mercury report even hints that Diffusion's efficiency could open room for multimodal expansion, pairing text with diagrams, audio descriptions, or even quick video scrubbing using one architectural family instead of stitching separate specialist models. The paper also covers scaling laws. Their larger small model beats mini by a clean margin on every benchmark, implying performance should keep rising as they release medium, large, or beyond. Because each denoise pass is still one forward transformer run, bigger layers could mean both a richer model and even more parallel work per pass. So speed might climb rather than fall, up to bandwidth limits. One spot where Mercury Still Trails is bash scripting 50% accuracy for Coder small versus Gemini Flash's 51%. That shows there's room to train on more shell samples. Yet in JavaScript, TypeScript, and C++, the diffusion model already matches or edges past most rivals. And its fill in the middle scores 93% for single-line gaps in small, top the charts. These fill in the middle tasks matter because real coding assistants often work by dropping hints exactly where you are typing, not at the end of the buffer. If you want hands-on proof, Inception Labs runs a free playground at chat.inception.ai. Paste up to 128,000 tokens if you're brave, watch the spinner, and notice how little delay there is before full paragraphs appear. They do throttle heavy users, but it's enough to feel what sub 100 millisecond code completion can look like. The bigger picture is that Diffusion just stepped out of the image world and into the programmer's chair. It isn't tossing out transformers, it's reusing them in a fresh sampling loop. That finally breaks that left to right handcuff. If you build developer tools or maintain giant internal code assist systems, the arrival of 700 plus tokens per second at solid accuracy changes capacity planning overnight. Alright, that's it for now. If diffusion models are already this fast and accurate, what's stopping big players like OpenAI and Google from switching everything to this approach? Or are they just protecting what they've already built? Let me know what you think in the comments. Don't forget to like, subscribe, and turn on notifications for more deep dives into the world of AI. Thanks for watching, and I'll catch you in the next one.